And that way we can double check some work here if we need to. So here it says identify A, B, and C, and then solve using the quadratic formula. So 9.1, identify A, B, and C. So we have A equals 1, B equals 18, C equals 80. And then we should just be able to go right into the quadratic formula. That is that x is equal to negative b plus or minus b squared minus 4 times a times c under the square root all over 2a. Chat, is this going to be big enough? Is this actually going to give us something? Is 18 squared bigger than 4? I guess it's bigger than 4 times 80. Okay, sure. So let's go negative 18 subtract. We'll do a square root of 18 squared minus 4 times 80 all over 2. So the negative solution is 10, and if we pop back in to get the positive solution, I can basically just kind of update this particular sign to a positive sign. The positive solution is negative 8. So I get, what was it? Was it negative 10? Oh no, what happened? I broke it. Was it positive 10 or negative 10? Why, are you finding, I'm curious, like, just are you finding your studies a little bit more challenging, or? And I wouldn't, honestly, I wouldn't go out of my way to say that I'm certainly not like a natural by any means at mathematics. It took a lot of work for me to like understand a lot of stuff. So I think it's negative 10 and negative 8 here. So this is going to, now it's positive. Yeah, so we should get negative 8 and negative 10. So they say enter your solutions as a list of integers separated with commas. I don't know if it wants like maybe the negative 10 first and then the negative 8, but something like that should hopefully fit the bill for that particular question. So I guess we can multiply all of this by negative 1. So we really have something like 2x squared plus 9x plus 9 is equal to 0. And what we probably want to look at is b squared minus 4ac. So b squared is 9 squared. Take away 4 times 2 times 9. And we're looking to see if this number, 4 times 2 times 9, is larger than 81. I don't think it is. So let's do 81, take away 4 times 2 times 9. And we get the number 9. Oh, that's actually a perfect square number. So when I go to think about what my solutions are always negative b plus or minus this number under the root all over 2 times a. Now, if this number under the square root was 0, then we'd only have a repeated solution, this one single repeated solution. But because this is a perfect square number, my solutions should be given by negative b plus or minus 3 all over 2a. So I should actually get...
That's all right, little Hank. It doesn't matter if you have the beard on the outside, as long as you got the beard on the inside.
Hello, Don. How are you doing? Welcome on in. Happy Sunday. So I do think we're going to get 2 solutions here. Now, this says 2 different rational number solutions, 2 different irrational number solutions, or 2 imaginary number solutions. So we definitely don't have this. We definitely don't have this. I don't think we're going to get imaginary solutions because the square root is positive. I think we're going to get 2 different rational number solutions because b squared minus 4ac happened to be a perfect square. So I think those will come out to be rationals. So I guess we'll just go with the quadratic formula. I can't divide by 5, so we'll just dive into it. So we'll go negative b, which is negative 15, plus or minus, we'll go b squared minus 4 times a times c. That's our square root. All over 2 times a, which is 10. But let's try quad formula. So let's go negative 15. I'm going to go with the positive root first. So we'll go 15 squared minus 4 times 5 times 4. So 4 times a times c. That looks fine. And then we'll go divided by 2a, which is 10. Oh, okay. So we are going to get some terrible answers. So we'll get negative 15 plus or minus root 145. So it is not going to be a super nice number. Now, which one's smaller? Negative 15 minus root 145 over 10 is smaller? And then negative 15 plus root 145 over 10 is bigger. So the one that we have is the plus root. And if I change that into a decimal, I get like negative 0.296. So negative 0.296. And we could go back and I guess just alter this plus sign to a minus sign. That should give us the... Huh? Okay, that's weird. I guess they factored the minus sign out. That feels a bit weird. But we should be able to convert that and get the smaller of the two roots, which is negative 2.704. I think 704. Yeah, I'm okay with that. Posted question and work. Fantastic. No factors of 20 that add to 15. Yeah, exactly. So we couldn't quite make that one work. I agree. How many questions do we have? We have 7 questions altogether. We're on question 4. Let's do one more quick question here, and then we'll check in with punching and see what punching's got going on for us. So what do we think, chat? Consider the quadratic function 9x squared minus 1. What's its vertex? What's its largest x-intercept? And what's its y-intercept? Yeah, so if we want the vertex here should just be 0. It should be 0 and something, right? Because this is just an x squared that's been moved down 1, and we've just increased its amplitude effectively by 9. So it should have a vertex at 0. X equals 0, right? And we just need to find the y value. The y value is going to happen at the minimum, which, yeah, is usually, I think, negative b over 2a. Have you guys messed with the new ChatGPT? No, I wanted to, but then it wouldn't accept pictures, so I couldn't do it. I stopped playing around with it because it wouldn't accept pictures. Because I was trying to solve this stupid linear algebra question. So, fam, you're thinking it should be negative b over 2a should be where the y component is for our vertex. So negative b, so wait a second, there is no b. But y is definitely down. Oh, y is just down y1. So isn't it just like at negative 1? When x is equal to 0, then this thing is at negative 1. So I think the vertex is down here. The largest x-intercept is going to be this one. The x-intercepts happen when y is 0, so that happens when 9x squared minus 1 is equal to 0, so 9x squared is equal to 1. X squared is equal to 1 over 9. So x is going to be plus or minus 1 over root 3, if we take the square root of both 1 and 9. So the largest x-intercept should happen at 1 over the square root of 3. Now the y-intercept in this particular case, I guess, happens at the vertex, which is at -1. Oh, that's the x, not the y. Gotcha, okay. Oh, -b over 2a is how you find the x part. Gotcha, okay. So that checks out, that checks out. 3, not √3. Oh, yeah, that's correct, yes. I agree with you, yeah. So this should be 1 over 3. Also, Don, very excellent use of the of the solid snake notification. Much appreciated, much appreciated. I think that takes care of question 4. A function opens down. Yeah, I agree. Yeah, this function should open down. That's true. Right, that's because if we look at a, which is -4, -4 is going to tell us that this function definitely opens down. Let's see if the QEDs are working. Give the domain of the function using interval notation. Yeah, a parabola, I agree, is typically defined for all real numbers, so that should be fine. Give the range of the function. So is there an easy way to see that 0 does, well, I mean, obviously 0 doesn't maximize because we have this middle term of -8x. But is there an easy way to get at the maximum without having to complete the square? I don't particularly want to complete the square. Can we use Fem's idea that the maximum should occur at -b over 2a? And I'm mostly saying that because I'm not sure if my students are going to have access to the derivative quite yet. But they should have a formula that gives them access to the x and y coordinates of the maximum or minimum point. So in this case, we could take 8 over 2a, which is 2 times -4, which is -8. I see. So this is how we get that x coordinate of the maximal value. So that's -1. And if we take f at -1, what do we get? We'll get -4 plus 8 plus 14, which is 22 take away, well, 18, I guess. I get 8 and 10. So I still agree that 18 should be the maximal value. So that must be the largest y value we can get, which is 18. How does that look? Are you happy with that, Jeff? Oops, I mathed wrong. It happens. I mathed wrong. Yeah, if we take the derivative, what do we get? We get -8x minus 8. Set that equal to 0, so we should get x is equal to -1. Yeah, and then we just sub -1 in, so we should get... Oh, I see. Yeah, I see where you got your 22. We just forgot to subtract the 4. That should be good, though. I think 18 works. So let's fix x as the number of widgets, or at least let x represent that particular variable. Hi, Govan. How are you doing? Welcome on in. Hopefully you had a nice, relaxing weekend. So yeah, so I am under the impression that x is going to be... Or no, I guess that's not true necessarily, because the number of items that we sell is actually going to be dependent on the price, isn't it? So that's not quite true, what I was thinking. So I think that maybe the 300... So if we're dependent on the price, as the price goes up by $13, we would expect to see a 300 decrease in the number of items that we're selling. So I think that's what we're looking at for the slope of the demand function. Our demand function itself should be a y equals mx plus b kind of function. So we know the slope. The slope is negative 300 over 13. And we just need to figure out what b is. So what is our intercept? Do we have that information? It doesn't look like it, but we might be able to figure it out. So if we were to put in, let's say, 218 as our price, then we know that the output should be 14,000, right? Does that simplify to something nice? So I need 14,000 plus all of that business. That doesn't simplify to anything nice. Okay, what the fuck are they saying online? This is like a terrible, terribly worded question. So for every decrease, yeah, so they're taking x as the price, and they're saying for every decrease of 218, no. For every yeah, so I have the slope in the correct spot. What's this 218 represent? Why do they have x minus 218? Oh, that's the 0th. I see what they're doing. That's the 0th term. Because we know when x is 218, I get 14. Yeah, I see what they're doing there. That's a really odd way to do that. So I do have the correct slope. So I should be able to use this number, even though it's not a very pleasant number to get the job done. And we should be able to double check as well. So if I solve for b here, I get 19,030.77. So our demand function using the 0, like using kind of my solution here, should be negative 300 over 13x plus this. I suspect that theirs might be similar to this if you expand through the brackets. So I do think that this negative 300 over 13x plus 19,03077, I do think that's going to work here. I am happy with that. Now, if I want to find the revenue can be found. So the revenue function can be found by taking the demand function and multiplying by x. So if we take this demand function and we multiply through by x, we should get the revenue, which will be negative 300 by 13x squared plus 19,030.77x. So those I'm happy with. Those made completely 100% sense the last time we did this question. Now, what we want to do is we want to think about the cost of producing just enough to meet the demand. This is where things got a little crazy last time. Hi, Laz. How are you doing? Welcome on in. They want us to find the cost of producing just enough widgets to meet the demand. So what they were doing was they were taking the cost function and inserting the demand. Now, the cost function is variable costs plus fixed costs. So the cost function is usually something that represents the variable costs plus the fixed costs. And I'm used to, in kind of a linear sense, just calling this like the cost to produce each item in some kind of sense. And the cost to produce each item is usually given by the marginal cost. So if we happen to know the marginal cost, we're going to know what this particular value is right here. Now, how we're going to have to update this is we want to input the demand function here. So we're going to need the demand function here. So I'm thinking that the cost is going to be our marginal cost of $130.80. We're going to multiply by the demand function, which we found to be this function here, and then we need to add our fixed costs if we have any. The fixed costs are 12,000, so 12,000. So I think that that's going to be our cost of producing just enough to meet the demand. And maybe we could do some work simplifying this a little bit. So I could multiply this through and get negative 3,018.46x plus 130.8 times 19,030.77. And then we would need to add to that 12,000. That's a big number. Ooh, wow, that's big. So that should be our cost of producing just enough widgets to meet the demand. We're going to sub d of x into what we would normally have for our cost function and just try to simplify that. I am going to start changing this negative 300 over 13 to a decimal number. So I think we'll eventually have to solve for something. So we'll probably need to have those decimal numbers anyway. So let's see, negative 301846x plus a really, really big number. 2501,224.72. Yikes. The profit function. Profit is revenue minus costs. We have the cost function, we have the revenue function, so we can subtract them. So revenue function is this. We need to subtract the cost, so we're going to add 3018.46x and subtract this really big number. I mean, that should be the profit function. We can maybe simplify this a touch if we want to. I might as well just pull up the calculator here, too. What is 300 divided by 13? Let's get that as a decimal number. That is 23.08. So this is going to be negative 23.08. We need to add these two, so 19,030.77. And we're going to add the 3,018.46. That'll get us to 22,049, 22,049. And what was our change? 23.
Memory? Please, my memory is Zeta sharp. I never forget a thing.
Okay, there's our profit function. Find the price that will maximize profits. So ours is a parabolic function opening down. 100% agree. Where is the vertex? Is the vertex at negative b over 2a? Is that going to be the x value that we're looking for? So we have this number as our a and this number as our b. So the vertex, or the maximum profit for us, should happen at negative b. So negative 22,049.23. So negative b over 2 times a. And again, we are doing some approximations here, so it's not going to be perfect or exact by any means, but we should get a pretty good ballpark answer by doing this division. So 04923, let's divide that by 2 times 23.08. And we get about 477, so 477.67.